Well, hello everyone. I'm gonna try out something different tonight. So in the previous episodes, I've been trying to produce a sort of graphic user interface based purely on Canvas and JavaScript, and um, what I've been able to produce is basically just a way to sort of manipulates squares and lines on the canvas like this, right? So I was actually thinking of using this for several purposes. One of the things I planned to do with this was to create a linear interpolator, which is essentially just a like an equation or a mathematical formula that would soften the edges of these shapes produced by the trajectory of the lines here, so that I could maybe make some smooth trajectories for sprites in a video game or something like that. But I've already done something like that in the past, so it might not be so interesting to do all over again. Although I might, just for showcasing, I might do it anyway in the end. But the idea I've come up with now has more to do with using these very methods I've developed here, but for something completely different. So for a while, I've been looking for ways to sort of generate sound, like generate tones, sort of like a DJ might do in order to produce music, or just for creating special effects. And I have a bit of a background in electronics engineering. I'm actually a bachelor in electronic engineering, so I have somewhat of a knowledge of how sound waves work at an electronic level. And it's basically just a waveform. It's just electricity that goes through a coil inside um, of a speaker, and it just makes air on top of the speaker just kind of vibrate and create sound waves. And so the way that works is by using voltage values to increase and decrease the position of the diaphragm in a speaker. There has to be a video online somewhere to explain that. So I think it may not be so obvious if you're not familiar with the physics of all this stuff, but the point here is like just I guess just a short video should
Hi.
be enough.
In this
Um. Oh my God, my microphone is not connected. Sorry. There we go. So okay. So yeah, basically, it's something like this. I guess this explanation is a bit too long and difficult. Hmm. Well, maybe it's not worth looking making like a parenthesis to explain this, but the point here is the voltage going across the coil can be manipulated through code, which is really interesting because that way you can define the shape of the sounds that you want to produce on the speaker. And so I don't really know anything about sound design or how maybe sound design suites work, but I'm planning to create my very own little sound suite. And I have the intuition, pretty strong, it's pretty obvious to me that I can probably pull that off using this web audio API that I found on Stack Overflow. So I basically just googled how to generate sound waves using some using JavaScript, and what I came across was this stuff. So what we have here is basically a way to output sound waves, using math functions like sine. This is actually a library based on the audio data API, and I don't know if you guys can hear this, but this is a sine wave. So what this does is it just outputs this shape into the speaker. And so as you can see, this is a plot. So you can plot the sound and then you can input it into the code, and you'll get a different type of sound depending on the shape of the wave. So this guy over here, you can actually test different shapes, different waveforms, and you can compare. For example, this is a square shaped sound. This is a triangle shape. This is a sawtooth. So it's interesting to notice like the differences in sound depending on the sound shape, on the waveform. I mean, now the objective I want to achieve here tonight, it's probably gonna take too long because I'm gonna have to do probably a lot of mathematical manipulation in order to get to the point that I want. But what I want to achieve is I want to position the squares in such a way that they, form maybe a sine wave, and maybe take that and maybe move it around, shape it around so that maybe half of the wave is a square wave and the other half is a sine wave. And so that's because I'm really curious to know what kind of a tone that would produce, on a on the audio data API. But there's a lot of implications of how to do that, because first of all, I'd have to define like the period of time that this little canvas here would represent. Like how much time would it be? Would it mean to have like from a 0 pixels here up to the total width of the canvas, right? And also, it's going to be complicated because if I have a square here and then another square here, and then another square here, and I want to, start from here and have the voltage, the values, rise all the way to here and then drop all the way to here. I'm gonna have to find a way to, define the formula to start from this point and finish in this point, so that all the points in between get stored somewhere in the code, and then they get so that they can get passed on to the sound card, and the sound can you know you can hear the sound in the end. And that's basically what this episode is going to be about. It's going to be about me trying to pull that off. Now, I sort of had the feeling that maybe I should keep this to myself, because I think it sounds kind of interesting, and I haven't seen anybody else try to do something like that online. But maybe I'm wrong. Maybe somebody else has already tried. But at least for me, it might have some commercial value. I just hope nobody nobody tries to steal my idea, as this is just an experimental video blog about me just coding improvised artistic, so pseudo artistic projects. But anyway, I'm gonna sort of just go with it and try to pull it off as fast as I can, to take credit for it or whatever. But I don't really mind. I mean, it's like I'm just doing this for fun. This isn't really for commercial gain or anything. So, um, well, I mean, unless somebody is watching this and they think it's interesting and want to hire me to work on more sophisticated stuff, but it's just me coding. Anyway, I guess the point where I'm gonna start, I did my research before this. This is a very interesting BBC article on the subject, and it has some really nice pointers and directions about what sound is, how it works, sampling and all that stuff. Each tiny sample from the sound wave, how it all comes together and how it works. Um, but it doesn't cover a lot of the code, and I guess this graphic here is interesting because it shows the availability of the web audio API, which seems to be pretty well supported among browsers. So I'm probably not gonna have a lot of trouble with portability. It's probably gonna be visible, audible on across a large amount of browsers. And it's just the Stack Overflow post, which is kind of old. Um, yeah. pretty old. But anyway, I guess I'm just gonna try to get on with it. So the first step I'm gonna take is I'm just gonna create like a new workplace here. Um, and the folder where I've been working, I think, is called uh, behind the scenes, and then just coding behind the scenes. This is where I have all my projects. So I'm gonna call the folder Soundwave. I mean mkdir Soundwave, and then enter the folder Sound. And so I guess I can just open this and where is it though? Where is my new folder? Here it is. So I'm gonna create a new file, and this file is gonna be called sound.html. And I just hope that the example from the Mozilla documentation works right out of the box, like just copying and pasting it like this. Cause it's just I'm gonna just take this and gonna try to sort of work with it, play around with the values, try to figure out what each thing means, and just try to output square waves and sine waves and all that stuff. And by the moment I'm done with that, I'm gonna try to incorporate the lines with the squares here, so that I can tell it what shape to output here. Maybe add a couple more squares and stuff like that. So, okay, just gonna save this, and I'm gonna try to serve it. Okay, so it's 440 hertz. Oh man, it doesn't work out of the box. That that's not good. Yeah, it's not good at all. Okay, so why is that though? Hmm, let's try to make this, I don't know, a bit pitch a bit higher. Yeah, something's not really working here. So let me see here. There's some sort of JavaScript. Oh, there we go. On-call type error. Audio.mod setup is not a function. Add new audio date destination sound HTML line 15, line 73. Failed to load resource. The server responded with a status 48404. Oh, I see. So okay. So something's not really working here. Hmm. Okay. I haven't really tried to load like external resources using JavaScript, so I'm kind of at a loss here. But it's okay. I'll try to find my way through. So I guess I'm just gonna use good old Stack Overflow. Uh, good old Google. Audio data API. Hmm. Okay, sure. Reading audio. Okay. Hmm. Writing audio. Yeah, no, that's. I don't want to use the audio. Complete example, creating a web. I guess this is the exact same page I was looking at before, right? Or has something changed or something? Where is the other page? Yeah, it's the same one. Oh, except. Yeah, except it's just linked there. It's just the anchor. Hmm. Okay. So. Okay. Okay. Let's see. Hmm. Let's see what Stack Overflow says here. I'm investigating using the Mozilla Audio API tone generator. I like this tone on a 500 millisecond. Actually, it does seem to work fine for me. I changed the loop in your request sound data function like this. Okay. Okay, so let's check out this JS fiddle. Okay, so it's the same example, but this guy says it works. It doesn't seem to work though. Hmm. Oh, that kind of sucks. Okay, I guess I'm gonna try it on Firefox just to see that if it's really working there. Okay. No, it's not working. Not even working here, either. I mean, the sound is working, but it's not really working here. Uh, so maybe the code is outdated. I guess I might want to use this code instead. So it says, during a recent hackathon, I decided to build a multiplayer 8-bit sequencer using sounds generated programmatically with the audio web audio API. So is this like the same page? Oh no, it's a new page. Oh, okay, okay. So it's a new page, but I don't see. Okay, examples. Oh, here you go. Number of examples. Nice. Oh, okay. Web audio examples. Code examples that accompany the MDN web audio documentation. Developer Mozilla.org. The audio analyzer directory contains a very simple example showing a graph visualization of audio drawn with data taken from. Okay, so just audio analysis. I might use that later for something else, but not right now. So audio basics directory contains a few contains a fun example showing retro style boombox that allows audio to be played stereo panned and volume adjusted. Okay, right. Nice, but not really what I'm looking for. Audio buffer directory contains a very simple example showing how to use audio buffer. Okay, audio param, audio context, compressor, create media stream, destination, decode. Directory contains a simple example showing how web audio API, which can be used to output a stream. In this case, media recorder instance. Okay, media source buffer, offline audio, panner node, script processor. Step sequencer directory contains a simple step sequencer that loops and manipulates sounds based on dial-up. Stereo panner, stream source, buffer directory contains a simple example demonstrating uses method for more information. Okay, so tone. Nothing about tone generation. Mm, let's see. Okay, so maybe this guy. Okay, building the sequencer. Right. Broadcasting. Shared Ruby code here. So it's in Ruby. I wanna look for the. Uh, they want to only use HTML5 audit tag to limiting. First discovered. Hmm. Right. Okay. So maybe if I look for it here, tone. Tone control devices, tones. A simple library for playing specific tones, notes using Web Audio API, Tone.js. Okay, so tones. Okay, readme demo. Tones Web Audio API is pretty amazing. You can actually synthesize audio with JavaScript right in the browser. Okay, so that's what I want. Sound synthesis. The only problem is it's pretty low level and not exactly intuitive to work with. This library is meant to make it as simple as humanly possible to create pleasant sounding musical tones.
see a few demos of tones in action here. Okay. Oh, I see. I see. Okay, so I guess yeah, it's I don't want the human friendly stuff. I really just want to check out the code, so I can just copy this and okay. Oh, there you go. Type sign. Yeah, yeah, yeah. So let's see where the type of frequency fric node fric or node define function. Yeah, but like okay, sign OSC context create oscillator. Okay, so this I guess let's see oscillator. Right, right. Um, yeah. Okay, so what I'm thinking here is I guess I have to get familiar with the like fundamental um you know uh namespaces of the Mozilla API, audio API, because I'm not really familiar with any of this. But I guess this can be, I was actually thinking about creating videos about me just trying to find ways to, like, doing research in real time, which I know might be, like, extremely boring to watch. But uh, I guess it helps me particularly to sort of understand my own method. I'm sort of trying, I'm doing this as fast as I can, and trying to speak, thinking out loud, but it might not be very comprehensible for people listening to me, or looking at what I'm doing. But anyway, like, um, it's just, it's just for fun. Uh, so anyway, okay, so I guess the next step I'm gonna take here is I'm gonna try to familiarize myself with this, with the audio API functions I'm looking at here, which I believe if I check out the demo HTML, okay, tones and demo, right? So those two scripts here. Where could I? Let's see here. The demos. What this is? Okay, ambient. Oh, nice, nice. Right, right. Nice. Oh no, I closed it. Where is it? Oh no, here it is. Here it is. Okay, so I'm just gonna do this. I'm gonna start this repo. It's totally awesome. Totally cool. Yeah, okay. So this guy has kind of done what I want to do, but not quite. Hmm. Let's check this out. Demo.js. Ambient, song, interactive physics, piano. Okay. Interactive types. Yeah. Huh. Play. Sure. Demo. Demo require .js. Hmm. I'm trying to find like where the repo actually, you know, like loads the audio API, or if it's like something that just, gets loaded automatically in every browser. I don't know. So, okay, I guess what I'm gonna do is I'm gonna try to start to track down the native audio API functions the guy is using here. So let's see one that sounds like really characteristic of the Mozilla audio APIs. frequency, play frequency, function, frec, this attack, attack, release, envelope game, this context, create gain. Okay, so I guess context. What is context? New audio context. Okay, WebKit audio context. Okay, window WebKit audio context. So let's check this out just to see what this is. Oh, and I'm also gonna bookmark this and like it. Let's see here. Okay, so this web API, audio context, constructor, properties, methods, close, create media. Okay, so it's like kind of the canvas of sounds. And that context part here has like this context destination, current time, okay, volume, current time, gain, context, current time, destinations, okay, does all these things. OSC, I guess the oscillator is the one that, mhm. Okay, context dot create oscillator. There we go. Okay, so I guess oscillators are the ones, are the kinds of objects I'm sort of, let's see, custom audio context oscillator, something like that. Oscillator node type, oscillator set periodic wave. Oh, here it is. Periodic wave, a periodic wave object representing the waveform to use as the shape of the oscillators. Oh, this is probably what I'm looking for. Okay, periodic wave interface defines a periodic waveform that can be used to shape the output of an oscillator node. Excellent. Okay, I think I found it. Okay. Constructor, periodic wave. Creates a new periodic wave. Properties, none. Also, periodic wave doesn't inherit any properties. Methods, okay, real, imaginary. Okay, so following example illustrate a simple usage of create periodic wave to create a periodic wave object containing a simple sine wave. Okay, so real, imaginary. This works because a sound that contains only a fundamental tone is by definition a sine wave. Here we create a periodic wave with two values. The first value is the DC offset, which is the value which the oscillator starts. 0 is good here because we want to start the curve at the middle of the -1 plus 1 range. Okay. The second subsequent values are sine and cosine components. Oh, so it's not, this isn't so, this is not what I want to do. No, no. This, no, of course not. Ah, so I would actually need some sort of a fast Fourier transform or something like that in order to, like take my take my own project, you know, sh- give it some shape here and transform this into like the, oh my god, where is it? Into a sort of, components here. Uh no, this isn't right. Using the web audio API. Okay. So no, I want an oscillator, but I want it to work by using samples. Okay, now let's see. Okay, so this isn't really what I want. Oscillator no type. Okay, so maybe it's a different type of oscillator. Sine wave, square wave, sawtooth. Okay, custom waveform. Type custom manually instead. Method to provide the data representing the waveform, doing so automatically. Sets type to custom. Set periodic wave. Parameters periodic wave. Oh my god, there's no other way to do this. Type is custom. Oh no. The periodic wave interface defines a periodic waveform that can be used to shape the output of an oscillator node. Oh, oh dear, it's the only way. It's the only way to do this. Okay, so maybe I guess I have the mathematical background to do this, but It's gonna take much more work than I thought at first. It's gonna take me a couple of days to crack this open. Um, create periodic wave. Okay, let's see. Create periodic wave. Let's see. Base audio context. Okay, syntax, real image. An array of cosine terms, traditionally the A terms and the B terms. The real and imaginary arrays have to have the same length, otherwise an error is thrown. Okay, constraints optional. An dictionary object specifies whether normalization should be disabled. If not specified, normalization is enabled by default. It takes one property, disable no normalization. It's the same page, the same page. Okay, parameters. Right. Hmm. Real and imaginary. Right, so it's just two arrays of sine and cosine components. Oh my god. Okay, so let's see, what are the parameters for create periodic wave? Create periodic wave expects two arguments. Both are float32 array instances that specify coefficients of a Fourier series. The first is the real portion, which is an array of cosine terms. The second is an imaginary, which represents sine terms. Is there a specific problem you're trying to solve, though? I have a feeling that just knowing that the args are full probably isn't going to. So I have to add arguments like this. Okay, get it, period code. Okay, so I guess what I want to do is convert samples to periodic wave. How to convert a wavetable? Oh, there we go. How to convert a wavetable for use in oscillator nodes set periodic wave. Oh my god, this is probably the answer to what I'm. Yeah, from 3 months ago. Since you have a periodic waveform defined by a function, you can compute the Fourier series for this function. If the series has an infinite number of terms, you'll need to truncate it. This is a bit of work, but this is exactly how the predefined oscillator types are computed. For example, see the definition of the square wave for the oscillator node. The periodic wave coefficients for the square wave were computed in exactly this way. If you know the bandwidth of your waveform, you can simplify the work a lot by not having to do the messy integrals. Just uniformly sample the waveform fast enough and then use the fast Fourier transform to get the coefficients you need for the periodic wave. Additional details on in the sample theorem. Okay, Nyquist's Shannon sampling theorem. Hmm. Okay. So this is gonna be harder than I thought, but okay. Thanks, computing the fast Fourier transform is the issue I'm having. I don't know how to implement that. The API implements a fast Fourier transform for its periodic table methods, but doesn't expose it. The example code I've seen uses tricks with sine and square waves to avoid doing the transformation. I can sample the wave at the audio context sample rate, but I don't know how to convert an array of amplitudes into the real and imaginary arguments for the create periodic table method. I cannot find any code to study, and it's taking me a while to get the grips with the math. If speed is not important, just implement the formulas of the discrete Fourier transform, or do a search of JavaScript FFT. There are lots of JavaScript implementations of an FFT. The transform will produce an array of complex values, or two separate arrays. The real part is the real parameter, and the imaginary part is the image parameter of the periodic table. I couldn't find any maintained libraries that implement FFT in JS. Other people have had the same issue. An implementation of an FFT doesn't need constant upgrading. It should just basically work. I wrote one long ago for Chrome. It works for what I needed, and I don't need to update it constantly. May not be the fastest, but fast enough for me. The alternative is to compile up your favorite FFT code using Wasm to run in the browser. No worries. Thanks for your help. Oh, so I believe we've come across a roadblock. Hmm. Okay, so I guess maybe somebody somewhere could have created a fast Fourier transform to convert samples into, you know, this for the oscillator. Ah, okay, so let's see. JavaScript, FFT, FFTJS, NPM. Simple pure JavaScript implementation of the Cooley-Tukey algorithm. Node FFTJS. Small efficient JavaScript FFT implementation. Okay, let's see. Uh-huh. JSFFT, small usage, uh-huh. Ships with a complex array which can be operated on. Okay. Frequencies. Frequency real, frequency image. Mm-hmm. Okay. Data.fft. Implement a low pass filter using the in-place mapper. Okay. Frequency I frequencies.map. Alternatively, frequency space filters can be implemented via frequency map conventions, JSFFT. Hmm. Digital signal processing. Okay, so I guess what I'm gonna have to do is use this and try to connect it with the other code, but it sounds like it's gonna be tough. It sounds like it's not gonna be easy at all. Latest JS Radix to FFT, visualizing audio FFT in JavaScript, Stack Overflow. Okay, unlikely. 8 years and 6 months ago. Hmm. Right, right. You can search a Java FFT algorithm. Okay, following example. So I guess I'm kind of interested in like who this guy is. I wonder if they have like software as different view network profile. I wonder if they're on GitHub. Hmm, GitHub? No. Okay, no. Accounts, reputation, activity, top. Hmm. Yeah, because I might like to get in touch with that guy and get to, work on the same stuff they're doing, cause sounds pretty interesting. Hmm. I guess I can just, sort of, mm, but I would need some sort of indication about, like the frequency maybe. Um, ah, okay, okay, let's see. Um, the ingredients I'm going to use for this particular code are gonna be where's the FFT? Where's the FFT source code? I was looking at just a little while ago. JavaScript FFT. Where? I'm just gonna look for it again here. JavaScript fast Fourier transform. But from GitHub, not from. Okay, so yeah, maybe this, but maybe not this, but that. This thing here. FFT.js require FFT.js new FFT. It's 4096. Create complex array. Data has just real numbers, as is the case when two complex array is used. Real FFT may be run to compute it 25% faster. But like, I don't understand what this number means. Radix 4. It sounds like a bit of a learning curve. Maybe just this. Okay. JSFFT. Small efficient JavaScript FFT implementation for Node or the web browser. Ships with complex array which can be operated on. Okay. Data equals new FFT complex array 512 dot map value. Use the in-place mapper to populate the data. Okay, value dot real. Including the FFT module attaches FFT methods to complex array FFT and frequencies data dot FFT. Okay, const data. Alternatively, frequency spaces filters can be implemented via example. Let's check out the example. Okay, bundle index.js split example.js built with webpack. Okay, so element with height. See this. Okay, so maybe I'd have to sort of, check it out on raw. So like this. Mm-hmm. Sample data, new complex array 128. Okay, data, okay. Okay, right. Hmm. 1 greater than n minus 3, and 1 less than 2 times n. Value real, 1, 0. Okay, right, right. Ah, nice. Simple low pass filter, okay. Yeah, this is what I'm looking for. So okay. So these are 128 samples probably, which is 128 points here. And out of those, from the point where I is greater to n divided by 3, where n is 128. Okay, I see how this works. I understand exactly how this works. Perfect. Okay, so my this thing I made, these blocks, I'm going to sort of shape this part here from the, oh my god, where is it? With this, like each corner is gonna be a block, and like with this thing here, I'm gonna populate that data set, and then I'm gonna get the transform, yeah, and these imaginary and real values are what I'm going to input into the, like this Mozilla audio, not this one. No, this is junk. Like the Mozilla audio thingy that I want to get working on. Oh, so okay, I started at around 10 p.m. It's already been 46 minutes. I'm already a bit tired of all the research I had to do, but I guess I'm gonna just lay the groundwork for tomorrow, because this is gonna take a couple of days, probably a couple of days. Okay, so I'm just gonna sort of steal this example here. I'm actually just gonna clone this into my own repository because, yeah, I'm gonna clone this. I'm gonna start this as well. This is beautiful code. Thank you, DNTJ. Totally saved my day. Okay, so JSFFT. Here we go. I'm gonna just sort of fork this. What was the process to sort of get a submodule working somewhere? Okay, yeah, because I need a submodule. I don't need this. This is junk. This is not what I want here. No, it's not what's gonna. I'm just gonna create a straight out copy of this. Copy this into the sound.html thingy. Just save it here. And in this very folder, I'm going to create a submodule with the FFT um, repository, and probably also with the repository from the other guy. Okay, so I'm just going to put this here. And okay, what's this? What's this? No, it's some sources guide. No, it's not it. Let's see my bookmarks. Somewhere in here, there's a wave audio examples bit 101 tones. This is the one. Okay, so also this guy's repository, I'm gonna submodule it. I'm gonna fork it and submodule it. But I don't remember how to do that. Let's see how to add git submodule. Submodules. Submodules, starting with submodules. Git submodule add. Oh, there it is. Just git submodule add. So I'm gonna git submodule add this into my own repository, like just in Soundwave. So git submodule add this, the Fourier transform. Awesome sauce. And the git submodule add the tones because this one works. But I'm just gonna modify this so that I can feed it the output of this thing instead of having just sine and square and whatever wave. I'm gonna have like custom waves. So I'm gonna git submodule the other thing. Oh my god, I'm really excited. Oh wait. Oh, add, of course. I'm really excited about what I'm gonna be doing tomorrow. Oh man, it's I always regret doing this right before bedtime because I'm gonna go to sleep and I'm just gonna be thinking about all the all the fun I'm gonna have tomorrow doing this. But I guess the steps I took today are enough for an hour worth of work. Like it's um it's a lot of work for an hour. It's enough, I guess. Um, but yeah, I need to relax and go to bed because already it's getting kind of late and I have microverse tomorrow. So I guess this is it for tonight. That's the episode. That's it. That's the show. I hope you liked it. And if I don't know if you have anything to add or anything you want to tell me, suggestions or whatever, I'm right here. So thanks for watching, and I'll see you later. Bye bye.